Hi. So good morning, everybody. Welcome to OffensiveCon Day 2. So I'm here and I'm quite honored and sad at the same time because actually this slot was Grug's keynote and unfortunately he couldn't make it. So I've been asked to jump in and now I'm here and trying to fill this slot. Thanks. This talk won't be very deeply technical. Actually, I think Grug's talk wouldn't have been too technical at all, too. But, well, let's see. I'll try my very best to get you awake for the following talks. And just a little warning, don't take me too seriously. Just take me a little bit serious, so then you're good to go, basically. So first, a little introduction about me to get you all on the same page. My name is Jörn, or by handle Jörnchen, and my off-work hacking was mostly focused on Ruby on Rails. However, I think that, or I hope at least, that didn't turn me too much into a one-trick pony. My daytime work, I do security consulting at Security Labs, and I do this since almost 11 years now, since I kind of successfully dropped out university and joined security. So my daily routine consists of auditing code, doing pen tests, reviewing designs, and all that usual or sometimes even very unusual stuff a security consultant does. And of course, all this work needs to be written down in nice report. That's the least favorable part of the consulting job. But still, while this kind of 10,000-foot view on a security consultant's work is neither wrong nor is it accurate in any way or even meaningful, it can be better described in a bit other way. From even more distance, my job is to complain about what other people do. I'm getting paid to nag and finger point at people for mistakes they do in their work. And actually, this is kind of expected. At the end of the project, I should have a lot to complain about, a big report with a lot of findings. So, because otherwise you wouldn't have needed to hire a consultant in the first place, right? So, but security industry just doesn't only consist of consultants and hackers put into maybe a fancy shirt. But there's more what we call the security industry, and just to give a few examples, we got the whole exploit business, exploit writer stuff where you actually, well, for that you can actually say it's a business because those supply chains are quite interesting. So if you sell your ODA, I think you can never be sure where it shows up and when. And also I heard this work is paid quite well. And on the other side of the spectrum, there are those people who still believe they can save the end users' computers from malware and exploits by putting even more vulnerable parsing code in, let's say, their kernels or in some administrative context on the operating system. That would be the AV industry. And well, there are still also people who just run around with a little self-assessment sheet, and you fill it out as a company, and they check if you checked all the check marks right, and then you're good to go. Those are those compliance clowns. And then you can go ahead with your big data PII blob, which eventually will get stolen in the next couple of months. But at least you did this self-assessment and are compliant. Well, so there's even more about the security industry, at least from my perception, as one common ground, and there must be a common ground, otherwise we wouldn't put this all together under one big industry umbrella. So it's like securing the world and making the internet a better place for everybody, right? No. It's like when you're hacking, when you're doing IT security stuff, it's always about you feel either if you're doing the defense side, if you're analyzing some malware, if you're responsibly disclosing some internet ending vulnerability with the logo and the website and all this buzz about it, you feel like an internet superhero, right? And if you're writing a nice, reliable exploit, you might feel like an internet supervillain. But you feel like you get that adrenaline rush when you actually get a shell, hack a box, and all these things. And at the same time, people throw piles of money at you because you're the security expert. So basically, this picture describes it best how it feels like. Like you're the guy in the front and people throw money at you and you're super sexy and hot. That's what it's all about, right? We're all like badass and here we go. But honestly, we all suck. we're not that. We provide kind of on the defense side only spotty security. We just fix the hole here and there. Maybe the client gets owned anyhow 2 weeks later after our assessment. That would be kind of the worst case. Or if you write an exploit and then Project Zero comes along and just kills your bug, you would just want to die or kill Tavis or someone else, I don't know. So it's all pretty much focused on little spots, little patches we apply here and there, but the internet stays the internet and it's going to be hostile for a long time, I think. And we got quite some problems, some really well-aged problems. So just to have a few examples which are listed here. Excuse me. So cross-site scripting, it's like in legal drinking age worldwide. It's like over 21 years old, and still it provides a kind of never-ending flow of bug bounty money towards those superheroes which spot an XSS on some website which happens to be listed on Bugcrowd or HackerOne or somewhere. So did we solve cross-site scripting over the last 2 decades? Of course we didn't. It's still there. It's getting somewhere a bit harder if people actually try to implement a content security policy or sub-resource integrity or whatnot. But still, cross-site scripting is a thing, and it will stay a thing for a while. And SQL injection, like it was first really publicly documented by Rainforest Puppy in a FRAG paper almost 20 years ago, FRAG 54, and it's still a legit tag. I mean, you take SQL map and choose the right target, and ta-da, there's your data breach. You can make WikiLeaks happy or just put it on pastebin, hack all the things. That still works. Also memory corruptions. Well, that's gotten way more tricky than cross-site scripting or SQL injection. But I think since we're here at OffensiveCon, I don't need to tell you that memory corruptions didn't turn unexploitable since Smashing the Stack for Fun and Profit came out in '96. So it's just gotten a bit more challenging, and that's why conferences like this also happen, where you have a very specialized view on memory corruptions, for instance. But yeah, the actual thing again is we kill bugs almost exclusively by instance. Bug classes die really hard. But imagine if you, who of you wants to flip the switch which solves cross-site scripting forever? What would happen? Would anyone like to do this? See? Because some people might declare you the internet superhero, but a lot of bounty hunters won't be able to pay their rent anymore, and they will like maybe even kill you. I don't know. Yeah, so we got really kind of serious problems. This is still a thing. I just made this screenshot last night. Can you see it from the back? It's just a GitHub search for PHP code which contains like the get parameter and the string sudo. What could possibly go wrong? I mean, it's over 9,000 results, so this must be legit code, right? Yeah, and from my personal let's call it research, which involved GitHub. For me, this started in 2012, and when I first presented about Ruby on Rails mass ownage via some application secret being checked into to GitHub at large scale, like lots of applications were affected because the framework made it easy to do so. It didn't warn you about, hey, there's this file you shouldn't check in, and it didn't put it in some .gitignore file. This took the Rails project a while to get this straight so that your production secrets don't end up on GitHub by default anymore. But still this issue is present. And I've presented on this, based on this type of vulnerability, a rather special case around 1.5 years ago at EcoParty number 12. There this problem affected some kind of software that was an ISP management panel where you could configure all your customers' ISP, as an ISP you could configure all your customers' internet lines and potentially even snoop on them or set a new DNS, which should be sufficient for doing really nasty stuff to them. I just disclosed it, they patched it, they confirmed that they rolled out a patch to their clients and informed their clients. So I was good to go to give this talk. And 1 year later, that this happened, it's actually, I just fell for this Black Friday offer last Black Friday. So that was like, I spent $5 on Shodan and was like, oh, actually I could use this to double check if they all patched like how the patch rate was. And I did so because this type of issue can easily check by looking at the session cookies which come back from the application. So I just searched for the according cookies on Shodan, downloaded them all, verified that I couldn't abuse them anymore, but the patch rate was like around maybe 80%. So there's still a shitload of people which you could just do strange things with their internet uplink to. And no one cares, actually. That's actually kind of funny. But are there any lessons learned? What's the takeaway from this? Well, obviously no one cares about patching, right? But furthermore, GitHub dorking is still a thing. It's gotten quite popular, and there even, since I started, even tools got developed by people to do this a little bit better. And GitHub even started to warn users about committing like their own GitHub access tokens and AWS credentials and all that kind of stuff. This helps a bit. And they even warn you about when your code has dependencies which has known vulnerabilities. So they send you an email, hey, your code has this dependency, you should update it because there's a bug in there, and then no one cares, and then they nag you again the next month with this email. I don't know if it works. I hope it works a bit. But still some just maybe 32 characters long string ending up on GitHub unknowingly could break your neck. Not only your neck, but also the neck of all the people who rely on your code. Well, and this seems a bit like the root cause seems a bit to be a problem of abstraction. Rails in that case is really good at taking care of the needs of a developer by magically doing stuff under the hood for you. But this kind of magic, well, that can bite you pretty hard. So every layer you put on top of each other of abstraction and magic offers possibilities of new fuck-ups. And those fuck-ups are not even really recognizable to you because they happen like 1 or 2 layers down where you actually program. And this is not only the case for some high-level web frameworks, this is also the case for like, just look at C compilers. I mean, there were cases where C compiler with certain optimization settings just removed some security relevant code because it thought, hey, this is not needed and I can maybe evaluate this another way, or it never gets executed or whatnot. Even C compilers are a level of abstraction to your actual machine code, which can shoot you in the foot without that you even notice it because you trust that abstraction level. So now from the defense side. Let me introduce you to the mitigator. This little green fellow is something Halva came up with roughly a year ago, and the mitigator illustrates quite nicely the problem which manifests in mitigations. So mitigations are mitigations, but not solutions. So just an example, not executable memory mitigates memory corruption vulnerabilities, right? Everybody here should know this roughly. And well, since it's not the 90s anymore, we all know that this mitigation might be bypassed by ROP, return-oriented programming, which itself, ROP itself is based on a paper by Stelz about borrowed code chunks, which itself is based on a paper from Solar Designer from '97, which described first the return to libc technique to bypass such restrictions. So the NX bit did not solve memory corruptions at all. It just made it a little bit harder and a bit more complex to write some exploits. It's just a mitigation, so we shrug off maybe 80% of the attackers. That's pretty cool, right? But there's still 20% left over, and maybe this helps, I don't know. But generally, if you have a good security baseline, so if you don't need to run faster than the beer, you just need to run faster than everybody else, right? So that might help if you compile all the things and with the security flags and the NX bit and the stack protector. But still, there will be people who can exploit this. Also, a quick look at all those silver bullets, all those solutions. There are solutions you, as a kind of end customer, can buy from the security industry. You're like a normal person can buy stuff, security software, for instance, antivirus. Well, nowadays, antivirus offers, besides the old school signature-based approach, it has a lot of extra features like pretty cool zero-day detection and cyber attack protection and crowd-based AI stuff, I don't know. Well, I like to say that AV stands for additional vulnerabilities. As a problem, detecting malicious programs basically boils down to solving the halting problem. Adding even more attack surface within an AV engine itself seems not very helpful to me. And I find it quite interesting how we could end up in such a kind of unfortunate situation. By unfortunate, I mean that secure and usable computers for the masses just don't exist. They're not there. Like your iPhones, your Android smartphones, your computers, it's all like, I guess, I don't know, who thinks his mobile phone is secure from maybe Stefan or, I don't know, it's just, it doesn't work, you just have to hope that you're not targeted. But yeah, how could we end up here? Will this endless stream of vulnerabilities being disclosed and discovered and data breaches and people getting doxxed, will it stop someday? I mean, like the CVE numbering system just had a recent change where they made the number space, I think they made it like arbitrarily big, and they figured like 4 digits aren't enough anymore, so that speaks quite a lot. And now let's go a bit of bottom up and have a look at this. So on your mobile phone, there's the CPU, and please ignore the recent CPU issues and hardware issues for a few minutes. I'll think I'll come to those later. And your CPU runs the operating system, right? And this operating system has a kernel, and the kernel maybe has loadable drivers, and the kernel might run a userland program. And maybe that is written in C. And that userland program happens to be something like Electron, so actually a fully blown browser. And Electron runs maybe the Slack app, which itself is a bunch of JavaScript and HTML and style sheets. And if you now take this whole path from your CPU to almost layer 8, to almost yourself, like the whole path of the application being run with all these abstraction layers in between, could you break it? Who thinks you can break it down from CPU level up to application level with every little aspect of interaction, abstraction, interfaces? This is just not possible. I mean, to develop a threat model on such a scale in order to just enumerate the attack surface, you would spend maybe a couple of lifetimes, and when you're done, this is obsolete anyhow. So this just doesn't work. And yeah, there's more. Sorry. So now, whom could we blame for this huge amount of codes piled on top of CPUs? And who's responsible? Is it us, the hackers? Like, shouldn't we fuzz all the things? Like, there are people running around with fuzzers who can't even write exploits. So everybody should get a fuzzer, and we could report all the bugs and audit all the code. But for this, you need like something like Project Zero, capability-wise, but in scale. Like not one Tevis, but an army of. And this just wouldn't work, because just to paraphrase Linus' law here, given enough code, there's not enough eyeballs. You can't find all the bugs in all the code. That's just not possible. But whom to blame? Is it maybe those stupid developers? Like they just don't learn how to allocate their buffers properly, and they don't check the length fields. What's wrong with them? Like how comes they don't even sanitize this and that in and output? Couldn't we have something like mandatory secure coding trainings? That would help a bit, but still they would have deadlines which will make them fuck up some check, and there will be bugs in any case. But we could also blame maybe the chip designers. They can't even build the hardware foundation for us, which is secure. Like we just had this recently with all the CPU bugs. But really, whose fault is it? So I got a theory, and let me give you a hint. 1982, C64, Commodore 64. Who had a Commodore 64? Yeah, so Commodore 64 was, when it came out like 36 years ago, it was a decent computer at the time, right? It was cool. And that's now the important thing. A dedicated user was able to almost or pretty much fully understand this piece of hard and software, like from CPU up to this screen and all the programs you run. You were able to understand this quite fully, right? That was an easy computer. Nowadays, I don't even know what kind of interfaces the thing has. Maybe I know how much RAM it has, but then again, it's gotten very complex. So another hint for the question about whom to blame. This gentleman here is called Gordon. He came up with something which seems quite being responsible for this overwhelming complexity we have in modern computers. So anybody knows this guy? This is Gordon, and Gordon's last name is Moore. And Moore's law, I guess everybody knows it, but it just says that the computing power at a given price tag doubles around about every 2 years. But not only the computing power doubles, this increases constantly, even exponentially, but also the code and the code complexity kind of follows along. Like Slack is a perfect example. Like it's made constantly fun of eating all your CPU and your RAM. And well, come on, it's a freaking chat program. Why would it eat like 3 of your 4 CPU cores and waste a lot of your RAM? You just want to talk to someone. Do we need this? We're kind of trapped in a circle of this power rising and directly being eaten up by but just another level of abstraction. Instead of using this gained power over time for more wisely, we just add more eye candy and kind of questionable features. So we ended up putting code on code on code, and on the CPU. And sometimes even the CPUs are code themselves, at least partially, like virtualization. It's like that thing to keep you secure, right? You have a VM for your porn, you have a VM for your work, and you have maybe a VM for your cat pics, and so on. So So your work cannot see anything about your porn, and your cat pics are out of scope anyhow. But well, that dream was shattered quite recently with not only Meltdown and Spectre, but also Rowhammer helped a lot to break this barrier of virtualization. And yeah, hypervisor escapes are things too still, so that doesn't really save us. And I think there's more to find on CPU and hardware level in general. But so here we are. We piled all this shit on top of each other, and there should be or must be approaches which give us which give us back a bit of sanity in computing. So there are approaches. On the right hand side we have Postle's law, and we have Langsec on the left hand side. And both, unfortunately, just don't go well together. Like Postle's law dictates you to be merciful about your input, and that's actually a good standpoint if you just want to get your deadline and want to get this thing somehow working, and working mostly as expected. Well, you just make it a bit liberal about its inputs. And Langsec, however, wants you to parse kind of responsibly, where the responsibilities include to just do not try to repair malformed input. That would be kind of a sin in terms of Langsec. And yet alone kind of stuff like further processing input, you know it will break, that you shouldn't do. So Langsec is strict and Postle's law isn't. It's almost like you have the choice, blue pill, red pill, which way will you want to go? Either meet the deadline or make everything work, at least for the sales demo or for some conference demo, or just be strict and do it right and don't have weird ass vulnerabilities in your code. Well, guess what the people choose, right? You just want to make it work. This is how the whole world works. We just want to do it, and if it's just a dirty hack, it stays a dirty hack for quite a while, most of the time. So, well, so Langsec is one of many approaches which try to adjust the status quo of computing in a more secure direction, but that appears like fixing the unfixable sometimes. So at the end, there's still the unfixable layer 8 that us humans being humans, but I think that's kind of okay because I don't want humans to act like machines and vice versa. Like the most effective solution would be some kind of clean slate approach. Just burn all the shit down to the ground and start from scratch. But I got the feeling we missed that point. Like we can't just tell the people throw away your computers, throw away your smartphones, forget about Facebook, delete all your cat pics, and we start from scratch and build a new computer and a new operating system and everything's going to be fine. People won't like that. Like, you don't want to throw your voice-activated spy equipment, smart equipment in your bedroom. You don't want to go off Facebook just because it's not secure, because you didn't get hacked. So why would you get hacked? So just leave it like this. But the fun thing about all this stuff, like this wasn't there 20 years ago. It's just exploded with Moore's law. So that's again where the point where I kind of blame Moore's law, and it's just exploding in our face way too quick, and we don't even recognize this. So this is pretty much my conclusion. So it's like 20 years ago you could be a pro on computers in almost every aspect. Nowadays there are conferences like this which specialize in very narrow and deeply into certain parts, and we have a monster of security industry, computers, IT in general, which is barely to be kept under control, because it's just the whole computer doesn't, with all its parts, doesn't fit into your head anymore. It's quite unfortunate, but I think we'll solve the one or other problem over time. And yeah, I don't want to be now the old man yelling at the cloud, so I'll spare you further ranting about clouds and smart stuff you put in your orifices or Google or Facebook or Amazon and how this all connects together. Um, I'd just like to say have a great OffensiveCon. See you tonight at the party, and thanks for your time.